Okay, so here we're going to talk about how you encode text. BERT is one of the main encoders, bidirectional encoder representation from transformers, which means it looks at the context of words with words both on the right and on the left. That's the bidirectional. So it makes sure that your words are appropriate in the context of surrounding words. So here's what tokenization does. You put in words and it just turns them into tokens, which are just sort of arbitrary numbers to represent them. And you have special tokens, like this one is the start of a sentence. And then you do embeddings to embed them as high dimensional vectors. And these embeddings are actually meaningful. Words with similar meaning have similar vectors, and even the difference between words is preserved. So here's I've run the tokenizing. So down here, it had to download various pre-trained models, pre-trained information for the BERT. And here it is tokenizing these things. And you see here's the starting is 101 and the end of a sentence is 102. And notice a period has a special token and it has various things here and the same word used twice. But also notice that it's not really one token per word. And extension like ized for revolutionized is often tokenized separately. And there are various different token models. Anyway, all right, so now we're going to tokenize 3 sentences, which I think we've already done that. That tokenizes it. And now here's how masking works. Let me copy this one. All right, put it down here. And this is how it learns to understand the context of words. So the masked, here's a, all right. If you don't see any masked tokens, which I should see, and here's one.
Speak now.
It masked the word legacy
Based on
there. And so you see this was replaced by 103. So it picks 15% of the words to mask. That's how it works. And then it will try to predict this. It will learn to predict the missing word from the words around it. And that's how it learns. So now we can see how it will predict the masked word. So here's an example of a sentence. Artificial intelligence mask take over the world. It's going to predict that missing word using the pre-trained BERT model, which is a base BERT model for, I think, uncased text. And that's taking a little while. I'm just going to skip to the answer here. What it's going to show you is the probability. Oh, here I come. So the most likely 30%, 31% probability that the word would be can, and that will turn it into artificial intelligence can take over the world. And for 18%, it's will, and for 5%, it's to, and so on. And here you have this fragment S. So it's artificial intelligences take over the world. And you see all of these make sentences that are reasonable English, and it has predicted various possible words to fill in and the likelihood of them. So that's how it learns how to make sentences that look good. So the words make sense compared to the words around them. And the next thing is how to make paragraphs that look good. And it does that with masking. So you have 2 paragraphs, 2 sentences in a row, and half the time it replaces the second sentence with a random different sentence, and it can learn to detect whether a sentence is appropriate in the context or not, the same way. And so this is how sentence order is encoded. All right. And so here's the input IDs, and there's the attention mask, which starts out paying attention. So the sentences are marked. 0 marks the first sentence, and 1 marks the second sentence. It identifies which sentence it's in. So, and then you can practice, you train it by substituting the second sentence half the time with the wrong sentence, and it learns to detect the right sentence. So now we can try using it to do sentiment analysis. So we're going to get movie reviews from an online database. And the point of this is it's going to have The movie reviews come with a rating by how many stars the movie got, and it also comes with paragraphs of text. And we're going to try to train an AI to read the text and predict whether the movie is good or bad by understanding the sentiment of the text. So here you see the original data. This is the start of a long movie review. One of the other reviews said this, a wonderful little production. This is the worst movie. I've been a Mario fan. So that's the original data. And then it tells the sentiment is here, positive, positive, negative, positive, which I think, all right. And then we're going to have, here's the data without the sentiment. And so we're going to send the data without sentiment to a pre-trained BERT model to see how well it can tell positive from negative reviews. And that's what this does. And this is, of course, quite valuable in industry. If you have something like tweets or customer complaints or something by email or something, you might want to have an AI go through it and decide a general sentiment of them to decide how good your product is or to pick which ones you should respond to or something like that. So downloads the pre-trained model. And it's going to output a sentiment field. Which it'll add this sentiment score at the end. And the pre-trained model does not predict positive or negative. It predicts the number of stars from 1 to 5. And since I'm using a model somebody else made and trained, I'm sort of stuck with that, even though it isn't exactly what I want. So I decided to evaluate the model's accuracy by calling it wrong if it predicts a 1 or a 2 star, but it's positive, or it predicts a 4 or a 5 star and it's negative. Now, 3 stars is in the middle, and I didn't know what to do with that, so I didn't mark any of the 3-star reviews as wrong. So there's the deal. Now we have a sentiment for each of these calculated from the model, and now we can calculate how many of them are severely wrong in that they gave it either 1 or 2 or 4 or 5 stars in the wrong direction. You certainly could have other measures of quality, but that's the one I made. And so now we can see BERT got 6 wrong out of 100 movies. So that's pretty good. And that's what I wanted to see. So you get to understand a little bit about how words and sentences are encoded. All right. So that's this one. I'm going to stop that recording.